Dear students, while studying preparation of hydrogen, we have already discussed method of preparation of hydrogen by electrolysis of water. Electrolysis of water is not the only method of preparation of hydrogen from water. There is one more method in which we use water, and that is from action of water on active metals. What are active metals? You are already taught. The metals above hydrogen in the activity series of metals are said to be active metal because they are more active than hydrogen. And because of being more active than hydrogen, they can displace hydrogen from water. So, in this method we use active metals, all the metals, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. All these metals are more active than hydrogen. I don't think I need to teach you activity series of metals once again. I have taught you several times. And you must have learned the order of the metals in which they are arranged from top to bottom, because that is the order in which metals are arranged in decreasing order of their reactivity. So metals above hydrogen in activity series of metals can displace hydrogen from dilute acids, which will be the next method, by the action of dilute acids on active metals, and also from water. The difference is that for displacement of hydrogen from water, metals need to be not just a little bit more active than hydrogen, but quite a lot more active than hydrogen. For example, out of this potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, then hydrogen, then copper, then other. So we can with difficulty till iron metals can displace hydrogen from water, but not tin and lead, not at any temperature. So how the activity makes the difference, you will understand by these examples. Most active metals, potassium, sodium, calcium, can displace hydrogen from water even at room temperature, means without heating. How? See example. Sodium plus H2O. Sodium will displace hydrogen from water and will form sodium oxide, and then sodium oxide will further dissolve in water to form sodium hydroxide. So the final product will be sodium hydroxide plus hydrogen. Same way potassium, if we write balance equation, will be like this: 2K plus 2H2O gives 2KOH plus H2. Hydrogen is displaced from water when they react with active metals like sodium, potassium and calcium without heating, because these metals are quite a lot more active than hydrogen over here, and that's why with cold water even they can displace. Reaction with sodium and potassium is very vigorous and exothermic. With calcium it is comparatively less vigorous. The product will be Ca, not 2Ca, 2H2, CaOH whole twice plus H2. The summary is that most active metals like sodium, potassium and calcium react with water to form their hydroxide, and hydrogen evolves out in this process. Reaction of water and sodium you have seen in the lab as well, and you have seen how exothermic and vigorous reaction is of sodium with water. Then we come to comparatively less active metals. So what are comparatively less active metals? The next is magnesium. Magnesium is less active than calcium, so it cannot displace hydrogen from cold water, but it can displace hydrogen from hot or boiling water. The reaction will be like this: Mg plus H2O will give MgOH whole twice plus H2. The metals below magnesium, including magnesium, like aluminium, zinc, iron, etc., they can displace hydrogen not from even boiling water but from steam. You understand that steam has more energy than boiling water. So these metals, that is even magnesium, obviously if it can displace hydrogen from boiling water, then why not from steam? So obviously it will displace from steam only, but the difference will be it will not form magnesium hydroxide but will form magnesium oxide and hydrogen. Similarly with zinc as well, Zn plus H2, ZnO plus H2, then aluminium with H2 will form aluminium oxide, Al2O3 plus H2. Magnesium, aluminium, zinc, and now iron is the last metal which somehow can displace hydrogen from water but not even from steam directly. The metal itself, iron itself, should be red hot, and then when steam is passed over iron, then somehow iron can displace hydrogen from water. Other metals below iron cannot displace hydrogen from water by any means, though they can displace hydrogen from acids because displacement of hydrogen from acid is comparatively easy. I hope you understood. So just I'll write the reaction of iron red hot plus water in the form of steam, and despite that reaction is reversible, and a combined special oxide of iron called triferric tetraoxide is produced along with displacement of hydrogen by this method. 3Fe plus 4H2O, steam is H2O only. Steam is the form, means water with so much of the calorie of boiling water and of steam extra. So Fe3O4 plus 4H2. This is the method of formation of hydrogen from with the help of displacements of water with the help of active metals, sodium, potassium and calcium with cold water, magnesium with boiling water, then magnesium, aluminium, zinc and iron from steam as well. Iron especially when it is itself very hot and then steam is passed over red hot iron, then a reversible reaction takes place and hydrogen is displaced. If the hydrogen's form is taken away, then the reaction will not revert back, otherwise the reaction can revert back as well to form iron once again at the place of triferric tetraoxide. The next method of preparation of hydrogen is by the action of dilute acids on active metals. In this method, even tin and lead can displace hydrogen from acids. This method is used for lab preparation of hydrogen as well, and in lab preparation of hydrogen we use zinc rather than sodium, potassium, calcium, magnesium, aluminium, so many metals. We use only zinc. Why do we use zinc for the lab preparation of hydrogen, not other active metals? That we'll discuss only after discussion of lab preparation of hydrogen with the help of zinc and dilute acid like dilute hydrochloric acid and dilute sulfuric acid. We do not use nitric acid for the purpose. All this I'll discuss in the live class of chemistry this week.